Good afternoon, everybody, and welcome to LKAB's webinar on properties and installation of high-density concrete. So today you will have three presenters, myself, and I will be talking about material overview, the source, the properties and the grading. My name is Denise Roberts. Then we have Jack Sindhu from Camfaud Concrete, who will talk about heavyweight concrete, the strength, mixed designs, production and transportation. And then we'll have Andrew Turner from Camfaud Pumps, and he will talk about the installation, pumping, placing and formwork. So just a little bit about the three of us. Denise Roberts, Commercial Director with LKB Minerals, and I've been with the company for 30 years and have a background in concrete technology and an extensive knowledge of the use of heavyweight aggregates and their properties. Jack Sindhu is a technical manager with Camfaud Concrete. Jack has been with the ready-mix industry for 32 years, having worked for various companies in commercial and technical roles. He has worked on many special projects, including the London 2012 Olympics, the Shard, Crossrail, C610, including heavyweight concrete, Northern Line Extension, Vauxhall Tower, New American Embassy, and Bloomberg Building, amongst many more. And Andrew Turner, Special Projects Manager for Camfaud Concrete Pumps Limited. Andrew has worked for Camfaud Concrete Pumps for over 15 years. He has been responsible for many of Camfaud's special projects, including the Shard, Crossrail and Thames Tideway. So I will talk a little bit about LKAB. LKAB is a Swedish state-owned company, founded in 1890 with just over 4,000 employees, based in the north of Sweden above the Arctic Circle. In 2018, LKAB had a turnover of 25.9 billion SEK. So we have three mines in the north of Sweden: Kiruna, Svappavaara and Malmberget. Our current levels of stock will take us through to 2035, and we are already looking at the next level of mining to make sure that we have the sustainability going forward. We have two underground mines and one open pit, and we ship out of the ports of Narvik and Luleå. Narvik being a 365 non-ice port, and we have a railway that runs between Narvik and Luleå and via the mines. So looking at the production of magnadents, it's initially drilled and blasted and taken by truck, where it's crushed and then hoisted to the surface by a skip, and taken then to the concentrating and salting, where the fines for the ore are removed. This is all then taken to a crushing and screening operation, where it's further loaded onto trains and shipped all over the world. This is a picture of the equipment used for the sieving, crushing and magnetic separation. And we have daily production analysis and process of finished products for further transportation to stock in Narvik. So we're processing and stocking next to the railway. We're producing 4 grades of material, so a 2 to 20, a 0 to 8, a 0 to 2 and a 0.5. The blending can be done by LKAB, not necessarily in Sweden, but at many of our plants around the globe. And materials can also be milled to further reduce the size of the product. All products are produced to the standard of the BSE EN 12620. So magnetite is a black hard mineral with a rough surface texture. Its chemical composition is Fe3O4, and it's typically 65 to 70% Fe and ferrimagnetic. 65 to 70 based upon whichever grade it is. So the finer the material, the more Fe content. Specific gravity is between 4.7 to 5.2, and loose bulk density of around 3, depending on the grade. One thing that's really important for the concrete production is a low water absorption of less than 0.3%. So low water absorption means that we need less water in the mix in order to get the workability. The chemical analysis, if we're looking at products MD8 and MD20, they're very similar regarding the chemical content. They contain about 90% magnetite and 10% gang rock. They do not contain hazardous materials. The products are exempted from REACH registration since they originate from a natural mineral and do not undergo any chemical modification. For use in concrete, alkali silica reactive particles, free mica, chloride, sulfur and sulfate are present in very small amounts, but well below the limited values. There are no halogens, organic substances, pesticides, genetically modified organisms, allergens that are added into the product. So other surface values of the material has a Mohs hardness of 5.5, a polished stone value, which is the measure of resistance to polishing action. For instance, vehicle tyres on the road surface, and 70 is the norm. You can see these are well around that number. The aggregate abrasion value is a percentage of wear due to rubbing between the aggregate and steel balls used as abrasive charge. So the percentage of weight loss against original weight, and the lower, the better. We'll talk about thermal properties of magnetite. Magnetite, when used as an aggregate in mass pours, has the effect of lowering the maximum temperature of the concrete by acting as a heat sink. So heat is retained longer and released more slowly, helping to reduce the risk of thermal cracking. The graph to the right highlights a cross-section of a wall with normal and high-density concrete, showing the temperature gradient from the centre to the side, as measured after 124 hours. The density of normal concrete is 2.4, whereas the density of the high-density concrete is 4 tonnes per cubic metre. So this offers a reduced risk of thermal cracking. During the evaluation, different snapshots of moments in time have been analysed and are presented graphically here. And you can see that the high-density concrete reaches a far lower peak temperature and a much smaller temperature difference between the centre and the side of the normal concrete. This results in a reduced risk of thermal cracking. I emphasise a reduced risk. There is still a need to consider the thickness of the concrete and also to look at replacement cements if the concrete is very thick. But of course, as well as the heat sink reducing the risk of thermal cracking, you're also reducing the thickness of the concrete required for the same density. So again, that will reduce the thickness of the walls. And more thermal properties of magnetite. Magnetite has a high volumetric heat capacity, meaning that more heat can be stored into a material containing magnetite. Also, more cold can be stored in magnetite in the sense that more heat is needed to heat the material. So overall thermal conductivity and volumetric energy capacity are strongly above average compared to reported materials. It's a very sustainable material. It's chemically inert, non-hazardous and durable. It has an excellent resistivity to seawater. You can see from this picture here, this was a project that we worked on. It's called the Dragon project. And the material in that vessel was removed after 25 years, and the material was resold into a different application. The material has been tested by Deltaris, and it was found that the expected unchanged composition of the ore after an exposure period to seawater would be up to 50 years. Considering the carbon footprint of magnedense concrete, We looked at all these different references for the different types of materials that are used in standard concrete, and we analysed the CO2 per tonne produced for magnetite concrete aggregates, excuse me. So when we looked at a standard mixed design, looking at a density of 2.4, you can see that the magnet-dense concrete equates to a CO2 saving of some 23% per cubic metre of concrete. So moving on now to producing heavyweight concrete, I'm going to hand you over to Jack Sindhu, who's the technical manager of Camfaud Concrete. Hi, Jack, and over to you. Thank you.
Thank you very much. Hello, everybody. I'm going to go through producing heavyweight concrete, the production processes involved, any special precautions we have to take to produce the concrete, specialist batch instructions, touch a bit on mixed design, and how to lay the product, whether you can pump it, skip it. So I will discuss all that and answer any questions at the end should you have any. So if we move on, what we can achieve with heavyweight concrete. There's a lot of preconceptions. You can't pump the material, it's not usable, you can't place it correctly, and issues associated with that. We've successfully used heavyweight concrete for many, many years, and mixed designs and admixtures have evolved to make it much easier for us to use. So heavyweight concrete essentially has no differences compared with normal concrete, and the design principle is still compliant with Eurocode 2. Concrete can be pumped with densities up to about 3,900 kilograms per cubic metre. That's achievable with a good blend of magnet-dense, coarse and fines, which are usually 20S, 8S and 2S. So all mixed designs obviously take time to evolve. Once you've got the correct mixed design, there's no reason why you can't achieve a good mix to pump. And again, we've done this successfully many times. We can pump concrete at the same sort of revolutions, which Andrew Turner from Camford's will discuss separately after my presentation. We have pumped heavyweight concrete up to 1,000 metres. So yeah, there might be slightly higher pressure, but Andrew will go through that with you. As long as the mix is well cohesive, there's little segregation, there should be no reason why you cannot pump the concrete. Densities of up to 4,100 can be achieved with the magnet-dense material, but at those sort of densities, it will become more difficult to pump. So we normally tend to supply those higher density mixes with the skip mix, unless you blend some other heavyweight aggregate with it. So concrete, again, placed, compacted as normal concrete is. There's no special procedures, no special equipment needed. Just as any normal concrete, obviously just bearing in mind it's going to be heavier. So allowances have to be made for particular types of formwork to make sure they can sustain the pressure. If you're doing vertical elements, similar with slabs, if you're propping up a slab, you need to make sure it can carry the weight. Again, types of poker vibrator, dependent on application, but just as normal concrete, nothing special. And same as normal concrete, the weather conditions, prevailing weather conditions will affect the concrete performance. Whether it's hot or cold, you're still working to the relevant standards, so you have to take adequate precautions, whether it's curing or use of hot water. You can incorporate that, same as normal concrete, so nothing different. Same procedures apply as in EN 206 and BS 8500. So that was the achievables. So if we go on to production of heavyweight concrete, and I'm just going to touch a little bit on mixed design. So the aim is to produce a mixed design that's very, very cohesive and has little bleed even when placed. And particularly, this avoids any segregation and allows you to actually place the concrete successfully, either via skip or pump. Any concrete that's not correctly designed will segregate, and it will result in pump blockages and potentially issues with finish on the element that you're casting. But as I touched on earlier on, said previously, the evolution of admixtures, certainly the new PCE admixtures with open life, have helped us tremendously in achieving a lot of what we're doing today. It enables us to give an open life of concrete up to 8 hours without avoiding any segregation, hence allowing, concrete to get to site successfully at the required workability, deterring site to add water to it to bring up the workability, and allows us essentially for that concrete to go off at the same time, even though it's a longer open life, the setting time still remains unaffected. So certainly on the previous two large contracts we supplied, we've had open life between up to 6 hours if required, which means even if there's a break in supply, there's no issue. Say you're pumping the long distance 1,000 kilometre, we know that the concrete's not going to start to lose workability, segregate, and then go off. So from that point of view, very, very good. And once you start adding water and certainly to heavyweight concrete, not only is it detrimental to strength, it's also very detrimental to density as well, which is one of the reasons why heavyweight concrete is specified in the first place. And as everything else, with magnet dense concrete, we have to make sure that we have special batching procedures, trained staff, and that's done all well in advance to make sure that everything is done strictly in accordance with that procedure that we adopt to ensure we get a consistent product time after time. Just a typical one of our brand new plants at Silvertown that's probably about 8 months old. But from that, you can see that obviously we've invested a lot of money in kit. So you've got to have the right equipment for these specialist mixes. So this particular plant's got a 8-meter drum mixer, tilting drum mixer, and we've got very, very large storage capacity round the back. We've got facilities to bring materials in by boat, so that saves obviously tippers coming in and out the gate, so cuts down on road movements. And with having the ability of storage, ground storage, vast amount of ground storage, means that we don't have to rely on timed deliveries. So we bring the material in bulk, we actually store it, therefore we're able to service the larger jobs. So looking at the batching plant generally, if we just look at it as a general batching plant, you'll have obviously you'll have your ground storage, aggregate bins, you'll have batching an aggregate weigh hopper, a cement weigh hopper, then you'll have your water and additives. And the more modern plants will have a concrete mixer, as you can see in the middle. So effectively, aggregates from ground storage in a modern plant will normally get fed into the aggregate bins. They then go up into either overhead storage or directly get weighed on the belt, on the conveyor. So dependent on the mix design. And same with the water, it's normally weighed. Certainly at the plant I showed you previously, all our materials are weighed. So dependent on the mix design, all the materials are weighed and fed into either, in that case there, on that diagram there, you've got a twin shaft mixer. Generally a mixer, or it can be mixed directly into the concrete truck. Once mixed, assess workability, it goes to the site and it's either pumped or skipped. So I will go through various bits on the plant on the next slides. So effectively, you're looking at making sure that your equipment is fit enough to handle the extra weight and the attrition that may come from the magnet dense material. And any contamination must be avoided because that will result in a loss of density, because you'll be putting some fine material in there or lighter material, which will result in a lower density than specified. Coming back to mix design, I normally allow about 100, 150 kilograms of extra weight on the target. So if you specified, for example, a 3,600 density, I'd probably aim for about 3,750 to ensure you get the 3,600. And it always works. We've not had one load back on density. The density's always been correct. So you have to make sure those procedures are correct, avoid contamination, and make sure the materials are blended correctly. Aggregate bins and conveyors may require strengthening, depending on how much you're going to batch, because you will not be batching full loads of magnet dense. Because of the weight, For example, for a 8 metre truck mixer, you'd probably carry 4.5 meters, depending on density. So same with the mixer, you wouldn't fully load the mixer with 8 cube. You'd probably do half of that, or you'd even do half of that. You could even end up doing 2 metre batches, unless obviously you do strengthen the conveyor or the aggregate bins, because it will have it will cause attrition and wear. And aggregate storage, again, as I mentioned earlier on, we're actually quite fortunate. We've got quite a good yard at Silvertown where we can store vast amounts of aggregate on the ground. So it avoids time deliveries. We've always got material on stock. Just to give you an idea, we talked about 20S, 8S and 2S. That's basically some crude photographs I've taken of the material just in buckets. So you can see, obviously, the 20S is a coarser aggregate. You've got the 8S, which shows you what that typically looks like. So there's a bit of granular, bit of granular in that, and then you've got the nice fines, again, a little bit of granular, finer material with the 2S. So the optimum mix design will have 20S, 8S, 2S blended to make sure you come with the optimum mix design with very cohesive and no segregation, or very little segregation and bleed. So just touching on batching equipment. So I've mentioned that again. It says there, obviously, for 6 cubic meters, an average concrete weight is going to be about roughly 14.4 tons. So if we batch an equivalent heavyweight concrete, you're looking at somewhere around about a density of 14.4 ton again. Equivalent volume of that will be about 3.6 cubic meters. So you can see, instead of batching 6, you're sort of half the weight. It gives you some idea. And obviously higher weight means lower volume. So same with the truck mixer. As I mentioned earlier on, you can only probably carry between 4 and 4.5 cubic meters of the heavyweight concrete, dependent on density and dependent on the workability. We did the Crossrail when I was involved with that contract 610 for the floating track slab. We were doing 4.5 meter loads, and the target density, target flow was somewhere around about 680. So we were able to carry 4.5 quite successfully. I think we supplied somewhere around about 4,000 cube of that mix. Now, the other thing we have picked up with that big volume job was that once we've loaded the truck mixer, there's a different center of gravity within the drum. So the drivers have to learn how to actually manage to drive the truck mixer, because it does behave slightly differently. So they've learned over the years that, over experience and time, how to drive slightly differently to accommodate that center of gravity, and it is different to normal concrete. So that's something we've learned over time. And again, like everything else, safety is paramount, because obviously with magna dense heavyweight concrete, there's more weight involved than normal concrete. So even when on site, the customer has to ensure that they don't overfill skips, because obviously there's a restriction on weight the cranes can carry as well. So everyone has to be on that learning curve and be aware of what this stuff can do and can't do. So just quickly move on to compliance testing. So actually, what I should have mentioned on the evolution of the mix design is when we've evolved these mix designs, we've had to carry out certain things, because you're weighing smaller volumes of concrete than you would normally do consistently. Computerized systems take a bit of time to adjust to the weights of materials that we're batching. So what we've had to do is we do a lot of preparatory work if we overweigh what we do in those instances. So when we exceed or breach the BS8 500 EN206 limits, we do a lot of derivation trials to see what effect that has on the mix design. So all that data sits on the background as we start supplying, and the concrete mix and the batching systems learn how to cope with the materials. We've always got that information in the background, so we can ensure that we get very, very little concrete rejection, or if there is an issue, we can hit it straight on and we know what the effects will be. So compliance testing, every load, and I mean every single load we produce, will be tested for workability and density prior to being dispatched to site. We will also make a set of 4 cubes, which we normally test at 3, 7, 28 days. So that data's there. We don't test every load for cubes, but depending on volume, we'd make sure on a pour we've got at least 2 or 3 sets on a decent sized pour. So we've got our own data available if the customer needs it as well. Once the concrete arrives on site, the contractor must make sure that they do not add water to the concrete without talking to the concrete ready mix supplier, because as I mentioned earlier on, there's an effect on strength, and more importantly, as density is a primary driver of heavyweight concrete as well, there's going to be an effect on the density as well. It will reduce the density. So any water addition, if needed, needs to be agreed with the ready mix supplier and a procedure put in place for that. And it should be on the rare occasion that you need to add water. As I said, the modern technology, you shouldn't be adding water to this concrete. Any site sampling, as per any normal site, same thing. You've got to make sure it's done in accordance with the standards. So predominantly, we get a lot of issues where sites do not sample concrete properly, and you get issues with the cubes. But hence, we've got our own data to fall back on in case there's any issue. Got a couple of photographs there. Just shows you the last job that we supplied very recently to Tilbury Power Station, filling some large infill shafts with heavyweight concrete, target density around 3,600 with a flowing concrete, again sort of 650 target flow. So you've got the pump pumping straight down the shaft, and then you've got obviously a snapshot of the concrete in the hopper of the pump. And as you can see, it's very fluid, it's very cohesive, and there's very little bleed or segregation, which is what you want. Some photographs from previous job we've done before that I've been involved with. So you can see concrete can be finished very easily, placed very easily, and you can see the quality of the finish on the side of that slab is very, very good. There's minimal blowholes, and the finish is really, really good. And the colours, obviously, the colour's a little bit dark because that seems to come from the Magna Dense aggregate, which is quite dark. And I shall now pass you over to Andrew Turner from Camfaud Concrete Pumps, who will enlighten you on some of the placeability techniques, certainly by pump, which I mentioned earlier on. Thank you very much for listening.
Thank you, Jack. Yes, I'm Andrew Turner from Camfaud Concrete Pumps, and I just want to go through what we have to look at when we supply pumps to pump heavyweight concrete. So just to put my job in context, in the UK, most of the concrete pumps are owned by specialist concrete pump hire companies like ourselves, although some subcontractors will have them, specialist concreting subcontractors, concrete frame builders, etc., etc. And then when there are large jobs lasting several years where concrete pumping's an integral part, you'll find some of the major contractors buying them specifically for those contracts. But beyond that, in the UK, they're mostly with concrete pump hire companies. My company's been going 35 years. We're the biggest in the country. We've got depots all over the country. We've got nearly 400 pieces of major plant that we hire out. And it's all concrete pumping equipment. That's all that we do. Now, over the years, we've done many jobs involving heavyweight concrete. A lot of them are for radiation shielding, especially in hospitals and in nuclear establishments. We do a fair amount of work in the nuclear power stations in the UK. But also we do them pumping material for ballast, especially in foundations of buildings. and then the contract that Jack spoke about, and I'll show you some slides of later. We've pumped concrete that's used for vibration dampening, noise dampening. So one of the questions we always get asked, and I know Denise at LKAB gets asked regularly, is it possible to pump high density concrete? And the answer to that's a very emphatic yes. And then the subsequent follow-up question is, do you need special equipment, or do you need to modify your equipment if you're going to pump heavyweight concrete? The answer is no, not quite so emphatic no, because there's a couple of caveats that are coming up shortly. And then we've a range of concrete pumps in our fleet, and we use all of them for heavyweight concrete, picking the best piece of kit for the job. So we have static pumps. Typically they go out on site for 3, 6, 12 months on a contract. That's the largest one we have, and we pump heavyweight concrete, no problem with the static pump. And we've got these Camfaud pumps, mobile line pump, and this in essence is a static pump mounted on the back of a truck. So this tends to do a different job each day. So it'll be out on one site one day, wrap up, next day it'll be out on another site. And typically they would go in and couple up to an existing pipeline. Just occasionally they'll go out, take 50 meters of pipe with them and lay the pipeline out and pump through that. But normally they would go out to a fixed pipeline and pump that. And then the next two slides show our boom pumps, which is the type of concrete pump that most people are familiar with, where we're pumping through the boom. In this instance, we're pumping what we call off the back. We're bypassing the boom and we're just taking the concrete down to a ground line. Sometimes that might be a line up a building. So that's a mobile pump off the back. And then the last slide in that sequence just shows the boom pump, the way most people see them being used. Their most dramatic configuration with the boom out, pumping into in this case, water treatment works, but might be a building, might be foundations, might be a high-rise building. So the caveat now is, do we need to make any modifications? The only thing we have to think about really isn't involving the pumping of the material, it involves the placing of the material. And if we have to place, or if we're asked to place through the boom, we've a couple of things to consider. The first is that the machine is designed with outriggers to support the pump and the boom when it's pumping normal weight concrete. So obviously if you're pumping heavyweight concrete, the concrete's going up through the yellow pipelines you can see on the boom. We're putting more weight on that boom, and we're putting more weight on the outrigger which is supporting the pump. And obviously there's a danger there that the pump overturns. The other instance that we're worried when we go through the boom is if we're overloading the boom. Again, the boom is designed to take a certain amount of weight, a certain amount of loading. So there's a danger of bending or deforming the boom. So what we do if we're pumping heavyweight concrete and we're using a boom is we'll often, instead of having the end placing hose on the last section of the boom, what we call the tip section, we'll actually disable effectively the tip section and we'll move the boom back, normally just one section, but occasionally two sections. But we have had jobs where we haven't had to worry about those. In actual fact, the job that Jack showed a slide of earlier, where we're pumping down into a shaft, obviously the boom isn't at full stretch in that configuration. Normally there's one section out and all the other sections are vertically downwards, and in that instance the boom is perfectly safe. We've no danger of overturning the pump or breaking the boom. Excuse me. Right. So when we're pumping concrete, we're looking for three things to guarantee us a successful day, a successful operation. Obviously, we need the concrete to be right. and Jack's gone through that. And we need a good pumping system. Most people only consider that the pump has to be good, but we have to match up our pipeline and any ancillary equipment we have. And that all needs to be good as well, so that we've got a safe pumping system. And finally, we need the proper operators, experienced operators carrying out the pour. So the concrete is a key part of the success of any pour. And as Jack said, it's got to be a very cohesive mix. We don't want to see any segregation or bleeding. Normally that would involve a high cement content, high fines content. We like to see a consistence of F5 or F6. Sometimes if we're working off a boom, obviously it can be a little bit tighter than that. And then again, we like to see admixtures to help with the workability, retention, keep a good open life on the concrete. Important for long distance and high rise pumping, no matter what. But when we're working with heavyweight concrete, there's always a potential for problems. And if we've got a concrete with a good open life, if we do have any problems, it gives us plenty of opportunity to rectify them. And then the other thing that we say with the concrete is, if it's a critical mix, and most heavyweight concrete jobs are critical, then it's always safest to carry out some pumping trials before time. And the pumping trial should replicate the job that you're trying to do as best as you can. So there's a picture very similar to Jack's. You can see, I don't know what that is, 650 on the flow table, I think, and you can see it's a good cohesive mix, and there's no evidence of bleeding around the outside of that concrete. So coming on to the pumping system, we tend to favour Putzmeister and Schwing pumps, though there are others on the market and they're probably equally good. We stick with what we know. It's important to have a modern, well-maintained pump, and they have to have good, well-adjusted wear parts. If it's not a good pump in terms of the wear parts, the problem you get is all the cream, all the fat out of the mix gets pumped back into the hopper, and then you're just trying to pump stone down the pipeline. So before we go into any contract of any decent size, or with special aggregates like heavyweight material, we'll always either change the wear parts or adjust them up, so that we're not going to lose that material back into the hopper. As in any job, you have to make sure that the pump has enough power and pressure capability for the job that you're doing. Obviously, if it's just through a 20-30 meter boom, it doesn't need to be such a powerful or high pressure pump as if you're pumping 1,000 meter pipeline. Whenever we have what we would call a special mix, and heavyweight concrete we always consider to be a very special mix, we'd always recommend using 125 mil pipeline. Two standards that we use in the UK, 100 mil, 125. Use 100 mil if you can, because it's lighter, easier to manhandle, but we wouldn't entertain a job using 100 mil pipeline if we've got heavyweight concrete. As for pipeline, it's got to be clean, not worn, because then the pressure rating comes down, and again, not damaged for the same reason. If there are any dints in the pipeline, you find that part wears more quickly than the rest, and obviously the pressure capabilities of the pipeline are reduced. And then obviously each pipe is joined to the next one with a coupling system, and those coupling systems always have a seal. Most of them will have a pin as well, though some don't. And when you are coupling the pipeline together, you have to make sure that you've got each and every component of it. Don't go into a job where half the seals are missing. And like the pipeline, they've got to be clean, not damaged in any way. So that's just a photograph which illustrates a pumping system. I mean, we've got 2 pumps visible and 2 more under that acoustic shielding. You can see the blue material at the back, and we've got a holding hopper in the middle, which is the higher vessel. And you can see our pipeline coming out of the back of the pumps, and the pipelines are tied into the floor using special brackets. So that's a whole system which is matched to the job and matched to the pressures that we expect to find on the job. So coming on to the personnel, who again are critical to our job. In the UK, the qualification for operating a pump is a CPCS qualification. There's one for just a trailer mounted static pump, and there's one for the mobile pump with the boom. But as well as having a piece of paper that says you know how to work the machinery, really on jobs of this type, you need experienced operators, and you need to make sure that they're competent. So there's Paul, one of our most experienced pump operators, pumped a tremendous amount of heavyweight concrete. This is a heavyweight pumping job that you can see here. Paul's been working for us for 25 years pumping concrete. And then a lot of people are scared of pumping heavyweight concrete, but we always think that if the job's set up properly, and if the concrete is good and consistent, you know, there's no danger of bleeding, we think you can pump at the same rate as you would for normal weight aggregate. And also, we wouldn't expect to see a rise in the concrete pumping pressures. I mean, that's evidenced from the job that we did that Jack's referred to, and I'll show you a couple of slides of it in a moment. That's Crossrail C610, where we pumped the floating track slab, and we pumped 1,000 meters of pipeline, and as I say, the rates were what we anticipated seeing, and the pumping pressures were as we expected. And in actual fact, we also on that job pumped some normal weight concrete, and the heavyweight concrete was the better of the 2 materials to pump. So in terms of placing the concrete, obviously you can place the concrete from the boom, but also you can place it from a ground line where the pipeline's manually handled. Obviously that has some health and safety implications with the handling of the pipeline. In terms of vibrating the concrete, on our Crossrail contract, the contractor was very keen that the concrete shouldn't be over vibrated, but to me no concrete should be over vibrated. I didn't think that that was an unusual instruction. I mean, obviously the big change, the big difference that you notice is the pressure on the formwork, because the density, the weight of the concrete in the form is much, much higher, half as much again, or whatever it is. So the shuttering contractor has to make sure that the shutter is well supported, and all precautions are taken so that that is sound, and there's not going to be any issues from the formwork. So just to take you through some slides of the Crossrail C610 floating track slab contract that we did, just to end up my presentation. On this job, I think we did about 90 pours on the job in total, of which 70 were pumping heavyweight concrete, pumping magna-dense concrete. And in total, of the heavyweight concrete, we pumped the best part of 4,000 cubic meters. We actually pumped a pipeline of about 1,200 meters with a normal weight, but the longest pipeline we did with heavyweight concrete was 1,000 meters, which I think everybody concerned with the job's considered a world record. We couldn't find anybody who'd claimed to pump anywhere near that distance. So when we had 1,000 meters of pipeline on, there was about 12.5 cubic meters of concrete in the pipeline, total weight of the concrete was 44 tons. So every time our pumps stroked, they were pushing 44 tons of material. And then in this contract, they were all night pours. And the reason for that was jobs in the middle of London, a lot of traffic. So obviously, if we're working at night, we're less likely to be affected by the traffic on London roads. So just a few photographs of the job now to end up. This is the start of the first day's work there, in fact. And so we've got 2 mixers there, and they're being tested. And then there's more coming in, and we wouldn't start this until we'd got the grout and at least 3 loads of concrete on site and notification that there were other mixers following on the road. And that's the first load of concrete going in. That's subsequent to the grout being pumped. And that gives you an illustration of the pipeline. On that day, we had about 900 meters of pipeline on. That wasn't our longest pour, but we had about 900 meters. And our pipeline is the bottom one on the left-hand side of the tunnel, the one that's supported on those red brackets. And that's the concrete being poured straight from our pipeline with a couple of placing hoses on the end. And as Jack pointed out, the magnet-dense concrete is very dark because of the material that's in it. And you can see that that flows very, very nicely out of the pump. Even, 900 meters away from the pump, that's still a nice flowing concrete. And there are the fellas finishing the concrete that night. Jack's pointed out, with that mix, you get a very, very nice finish on the concrete. The finishing gang are having no problem getting a good finish. And that's what it looks like once the job's done. And there we are. That's 5 in the morning. Our fellas trudging wearily back. They've just had a good shift. And then they look forward to coming back the following night to do the next pour. So that's me finished. So if I can hand back to Denise, she'd be more than happy to take questions from you.
Thank you, Andrew, and thank you, Jack, also. Thank you both for your presentations. So I think now we are looking at the questions that have come through. So we'll start with what is the difference between hematite aggregates and magnetite aggregates? And I'll take that one to start with. And the difference is that there are 2 different types of iron oxide. Hematite is an Fe2O3 and magnetite is an Fe3O4. So slightly different chemistry, and you tend to find that hematite is a red product, which can leach red into the waters, and magnetite is usually a black product. So next question, in hot weather, mass concreting, is it possible to cool the magnetite aggregate by chill water, say -3, so that peak temperatures, and then the question disappears, can be reduced? Sorry, can I ask one of you, Jack?
I will take that one.
Okay.
Obviously, on deep sections, when you're casting deep sections, I think you alluded to it earlier on in your presentation, Denise. The peak rate of temperature rise or the core temperature of the concrete will be dependent on type of cementitious product and ambient temperature. So yes, there's no reason why you can't chill the aggregate, but in the UK, it's very, very difficult to do because we don't sort of have the equipment to do it. You would treat whether it's magnetite similar to normal aggregates, so there's no difference. But certainly the type of cement you use, normally we incorporate 70% of a cement replacement, normally GGBS, which gives a low rate of temperature rise. Recent developments within the market, certainly with earth-friendly concrete, which we're looking at in Camfaud Concrete, that has a very, very low rate of temperature rise. So there's a potential of maybe incorporating that as a binder, which is basically contains no cementitious product at all. Still achieve your strength with very, very little temperature rise, and so there'd be no reason to really incorporate any chilling plants or ice plants. So one contract I can look back at is certainly the Olympics, where we had a chiller plant for water. We weren't cooling the aggregates; we were actually using chilled water. That has a little effect. Does contribute, obviously, in the hot weather. But certainly, you'd be looking at something like an ice plant, really, rather than chilling the aggregate, because I think that would be not possible to do. But I hope that answers some of your questions, and certainly, if you do want to come back to us, we can look into it further for you.
Thanks, Jack. I've got another one for you here. So, how do you design a self-compacting concrete with heavy density aggregate?
Well, when I touched on concrete mix design, it's all based on how you pack the materials together to give a mix that's homogeneous with very, very little segregation and bleed. So certainly the concretes we've been supplying recently, including the Crossrail one and the one at Tilbury Power Station, are designed to be very, very highly fluid, so that they're impinging on self-compacting concrete anyway. So that, you know, it's all basically down to the mix design, how we design it. I can't really give you the nitty-gritty formula, as much as I'd like to give you the formula for what we produce. But certainly, you know, it is mixed design. So that's achievable. We're doing it, and we can do it with Magnadents. There's no issue with any settlement of the aggregate. We found within certainly the recent concrete we supplied as well, that the aggregate is consistent throughout the slab or the element we're casting. We're not getting any sinking of the aggregate, which means it's a good, very, very good mix, and it needs very, very little vibration. So effectively, we have a self-compacting concrete on the shelf that's available now.
Thanks, Jack. One for you, Andrew. Do concrete pumps wear out faster with wear out faster with GGBS concretes? I think they mean Magnadents concretes, but
Magnadents.
okay.
Well, we anticipate that they will and do, but mostly the contracts we do, the actual volumes of Magnadense concrete that we put through the pumps is relatively small. I mean, you know, the Crossrail job that we've seen today is the biggest heavyweight concrete job we've done at 4,000 cubic meters. And our pumps will go out one day and do one job. Next day they'll be doing another job. Next day they'll be doing another job. So, you know, we wouldn't expect any one machine to be pumping vast quantities of Magnadents. So, you know, we don't generally consider it. It's not an issue to us.
Okay, thank you, Andrew. There's one here that I'll take. It says, what will be the specific gravity of aggregate used to produce self-compacting concrete? And our aggregates are ranging between 4.7 to 5.2. So on average, I'd say around about 4.9 would be the specific gravity of the aggregates in total. So I have another one for you, Andrew, actually. Which lubricant aid is used for pumping of heavy concrete?
So we would normally, I mean, like so many things that Jack says and I say, just good standard practice is what you need. So, I mean, we would sometimes hand batch a cement and water grout. For long distance pumping, we would ask the ready mix supplier to supply something similar. Occasionally, they'll put limestone filler in that to take out some of the cement. Or you can use a proprietary lubricant, pipeline primer, and really you pick the one that's suitable for you and for the job. Yes, and you know, the key thing really is not the product that you're using, but one, that you've got the right quantity of it. You don't want to be short, but equally you've got the right quality as well. So you don't want the grout, the lubricant, to be too wet, because if you're putting a material that's too wet down a head, you're likely to cause bleeding of the material at the front of the concrete that follows the grout. So standard practice, don't be short, always have enough grout and make sure it's the right quality.
Thank you, Andrew. Jack, one for you. It's a two-part question. How do you test the wet density and dry density? And for compliance setting, is testing done on 3 or 4 cubes?
Right. I addressed the first one. The first question you ask is on densities. So we will, at the batching plant, check the wet density because that's obviously what's agreed. So when we supply a project, we agree what's required as a wet density. We will do trials to determine what the dry density is if that's what they require, but that obviously requires samples to be dried over a period of time until it settles down to the dry density. So there is a difference between wet and dry. Normally supplied on wet because that's the only compliance testing that we can do and they can do if they need to on site. So an agreement is made dependent on specification with the contractor prior to starting. So that's that one. In relation to compliance testing for cubes, we normally do a set of 6 cubes. So as I mentioned earlier on, it might be 3, 7, 28. It could be 7, 14, 21, 28. It could be 7, 28, 56, whatever the project dictates. And to give us data. So for example, if we're using a higher GGBS blended mix, we may well want to test the concrete beyond 28 days. So we might do 56 days. So we're quite flexible, but bearing in mind the weight of the material, and the number of cubes that you have available, and depending on the size of the project, that will determine the number of cubes we make.
Great. Another one for you, Jack. Which lubricant aid is used for pumping of the? Oh no, that's. I beg your pardon.
Actually, I wanted to touch on that one. I know Andrew.
Okay.
Andrew mentioned the grout, so we came out with a grout mix. So the mix we were using on Crossrail had quite a bit of fly ash in it. Fly ash is becoming a very highly desirable material in very short supply. So we stockpiled the fly ash for that particular job to make sure we could start it and complete it. But anyway, the grout we did actually contained fly ash and it contained limestone filler, as Andrew alluded to earlier on. But as he says, the grout has to be right for the application. So at some points we were doing, I think we started off with 3 metre loads of grout effectively for the longer distance pumping. But consistency, mixed design, again, even for the grout, has to be right.
Okay. Another one, Jack, for you, impact of fines or sand on drying shrinkage. Could you talk a little bit about that, please?
Well, drying shrinkage, obviously, all concrete will shrink. Now, I haven't got any data to say what the impact of. Did you say fine sand?
Yeah, fines. I think they're talking about just fines in general, and sand being a fine product.
Well, without looking at historic data, I wouldn't be able to comment at this stage. I'll have to go back and have a look what effect that would have.
Okay.
Yeah.
Okay, thank you. Yeah. Well, we'll get back to them on that question then at a later date. Okay. Yep. Andrew, can we pump more than 4,000 kilograms per cubic meter density concrete?
We've never done it. I'll be honest with you. We've never done it. So obviously, the higher you go with the densities, the more problems you might expect. So I wouldn't say for certain that you could. Certainly, I would say, I think we were pumping a concrete of 3.6 tons per cubic meter on the Crossrail job, and that pumped very easily. I mean, it was a super mixer pump. So you would anticipate that you could pump a denser material if you've got the same magic behind it, but quite how far you could go on that, you know, I wouldn't know.
No.
Sorry, can I just quickly come in on that one?
Yeah.
The last contract we supplied to Tilbury, we were hitting somewhere around about, I think the highest value we got was about 3,810, something like that.
Yeah, yeah.
So
I've seen it pumped at 3.9,
yeah,
so about the same. So
I think, as Andrew says, and I agree as well, is as long as the mix design is quite robust and it looks good and it's quite cohesive.
Yeah.
I haven't really tried it. We've not really had a request for sort of 4,000 really, because obviously to do a 4,000 density with a bit of safety margin, you're looking at about 4,150, something like that.
Yeah.
To guarantee the 4. So I don't know. Might have to add something with it to get the 4 though. That's the only problem.
Yeah, we have recently just done a project where they pumped a 4.1, and that was with a fine iron. So we have. We'll try and send some more information on that out to the person.
What I would say is, if anyone wants 4.1, please give us a job so we can have a look, see if we can do it.
We'll be there. We'll be there.
Yeah.
We'll have a go at it.
Okay. Another one, Andrew, just for you. What is the maximum allowable pressure for operation of the pump?
Well, there isn't a maximum allowable. It's how safe the system is. So we have to match the pump and the pipeline and all the ancillary pieces of kit so that the pump isn't working or doesn't have the potential to work at a higher pressure than the rest of the system. The pumps that we used on the Crossrail job had a standard capability of 150 bar, and we had 130 bar pipeline, so we adjusted the pressure so that that was in line. So we adjusted the pressure to below 125 bar, but we weren't pumping at those. Once we got the system going, we weren't pumping at those pressures, but we had the capability, if we got a stiff mix or there was some delays or whatever, you know, that we could go up to that.
Great, thank you. And just finally, the last question I'm going to take on this webinar is in which applications is heavy density concrete used? And some of the areas in civil engineering can be hydrostatic pressure. So when we're looking at removing or reducing some of the piling, it can be used as a heavy slab to reduce the need. And of course, piling being extremely expensive. It's used in buildings of radiation shielding for hospitals and for nuclear decommissioning or new builds. And it can be used in things such as floating track slabs, which we did with Crossrail, where they're using it for vibration and noise dampening. It's used for ballasting. We can ballast offshore wind farms, such as Highwind. We just recently supplied for ballasting of those to lower the centre of gravity in offshore structures. It can be used in counterweights on bridges, Kent ledge blocks, and in excavators. So there's a whole range. There's a lot of information on our website if you want to visit there. We will actually go back and revisit these questions and hopefully put some more answers to them if there's anything we've missed. So thank you all very much for your questions. Thank you both Andrew and Jack for joining me today. And here, just to let you know, there are some more webinars coming up. Solutions for infrastructure with London Concrete, gypsum and the environment, thermal storage with magnetite using its thermal properties, ultrafine magnetite, that's when it's actually micronized to a very fine grade, and counterweights and ballast. So I hope you'll all join us there in the future. These webinars are in partnership with the ICT. The Institute of Concrete Technology's mission is to preserve and promote concrete technology as a recognised engineering discipline and to consolidate the professional status of practising concrete technologists worldwide. The ICT, in partnership with LKB Minerals, invites you to join a series of webinars on various aspects of concrete and flooring technology as an opportunity for professional development during the COVID-19 crisis. We hope that you've been enjoying them, and we hope that we're managing to teach some things. And thank you for joining us. These are the direct contacts for the three of us. So stay safe and hope to see you again soon.